Algebra of Matrices, Part 3. We've talked about scalar multiplication. Scalar multiplication, we take our scalar and multiply every entry in our matrix by that scalar. We've talked about matrix add and subtract. With matrix add and subtract, we check the sizes. As long as the size is equal, then we're able to add or subtract corresponding entries. Our next calculation on matrices is matrix multiplication. Matrix multiplication, we're looking at a row by column multiply. Every row of the first matrix is paired with every column of the second matrix. We multiply corresponding entries. After we multiply corresponding entries, we add all those up, and that single number is the result in the matrix multiply. And we'll look at how to do this. But for this to happen, for every row to match up with every column, we have to check sizes before we go through all this work of multiplying. Okay, so if matrix A is an M by N matrix, matrix B an N by K matrix, we check their sizes. These two numbers have to match up. This is the row of the first matrix. This is the column of the second matrix. As long as the row and column match up, we're able to do these multiply corresponding entries. So these have to match. If they don't match, then matrix multiplication is not possible. When it is possible, they match up, then the result is going to be, when I multiply A times B, the result is going to be an M by K matrix. Problem 14, perform the matrix operation, or if impossible, explain why. Okay, problem 14, we've got 2 rows and 3 columns. Here we have the second matrix, which is 3 rows, 2 columns. What we want to note is that these match up. Because they match up, then the matrix multiplication is possible, and we're going to end up with a 2 by 2 matrix. Okay, problem 16, we have 3 rows, 2 columns. Here we have 2 rows, 1 column. So what we want to note is that those two match up. Because these two middle numbers match up, that means when I finish the multiplication, we're going to end up with an answer that's a 3 by 1 matrix. Let's see how that happens. Okay, every row is going to get matched up with every column. We're going to multiply corresponding entries and then add those up for this position. Okay, 2 times 1 gives us 2, 1 times 3 gives us 3, 2 times negative 2 gives us negative 4. When I add these up, 2 plus 3 is 5, 5 minus 4 is 1, and so that is the entry that goes there. Okay, every row gets matched up with every column. We're going to pair up corresponding entries. These get multiplied. 2 times negative 2 is a negative 4. 1 times 6 is 6. 2 times 0 is 0. Then I'm going to add these up. Negative 4 plus 6 is 2. 2 plus 0 is 2. And that's the entry that goes there. Okay, every row gets matched up with every column. We multiply corresponding entries. So we're going to take 6 times 1, which is 6. 3 times 3, which is 9. 4 times negative 2, which is negative 8. Now these get added up for this result. So let's see, 9 minus 8 is 1. 1 plus 6 is 7. Okay, so last row with last column. We multiply corresponding entries, so 6 times negative 2 is negative 12, 3 times 6 is 18, and 4 times 0 is 0. We add all these up. Negative 12 and 18 would give us 6. 6 plus 0 is 6. And there's our solution. Okay, so there's our solution. Notice that we started out with a 2 by 3 matrix for A. We had a 3 by 2 matrix for B. These numbers matched, so that told us that we could do the matrix multiplication, and the result was going to be a 2 by 2 matrix, and that's what we see here. Now some of these get a little lengthy, so let's check our answer in the graphing calculator. Okay, so we're going to say second matrix A, second matrix edit A. Okay, so we have a 2 by 3 matrix. Okay, we're going to put in our entries 2, 1, 2, 6, 3, 4. Second matrix B, second matrix edit B. B is a 3 by 2. And so we'll put in 1, negative 2, 3, 6, negative 2, and a 0. Okay, so again, we want to make sure to get the correct answer. So we want to check our entries. Let's go ahead and see what we put in matrix A. 2, 1, 2, 6, 3, 4 looks good. Let's see what we put in matrix B. Matrix B, we put in 1, negative 2, 3, 6, negative 2, 0. Looks good. So now we're going to take matrix A. We're going to multiply that by matrix B. The matrix was possible, and there's our 1, 2, 7, 6, our 1, 2, 7, 6 that we got by hand. Okay, so let's go on to our next example. We check our sizes, okay, and we did on this one already, but let's go ahead and review. We have a 3 by 2 matrix. We have a 2 by 1 matrix. These are equal, so that means our result is going to be a 3 by 1 matrix. Okay, so we'll get this put into our calculator. We're going to say second matrix edit A. A is a 3 by 2. We'll go ahead and put in our entries. 2, negative 3, 0, 1, 1, 2. Second matrix edit B. B is a 2 by 1 matrix. 5, 1 are our entries. We make sure that we put in everything correctly. So we're going to say second matrix A, and that looks good. Second matrix B, that looks good. We checked that the multiplication was possible, and our answer should be a 3 by 1 matrix. Let's see if that happens. So second matrix A times second matrix B. And there's our 3 rows, 1 column, a 3 by 1 matrix. Okay, there's our answer. We have 3 rows, 1 column, our 3 by 1 solution.